Morning, we are on page 372, 6.1, problem 2. All right, my friends, I'm feeling like I should pull out the teacher's edition today just to make sure we do this right. 372, you're wishing you had one of these, huh? For the days when you're not quite sure. There we go. Marcus and Philip are in robotics class.
Really?
Any robotics people out there?
Not me. I'm a mechanic.
No robotics?
Brody, but he's not here.
Brody, okay. Marcus and Philip are in the robotics club. They're both saving money to buy materials to build a new robot. They plan to save the same amount of money each week.
What page? 372.
372.
Thank you.
You're welcome.
You
Number 1, memo. Could you read number 1?
Write a function to represent the time it takes Marcus and Philip to save money. Define your variables and explain why you chose those variables.
Okay. Save money. Let's see. They plan to save the same amount of money each week. Same amount of money each week. So this is interesting. They don't tell us anything yet. Oh, I guess the same as each other. Write a function to represent the time it takes for Marcus and Philip to save money. Define your variables. They have savings to buy materials. They plan to save the same, I'm looking at this, same amount each week. So I think we're going to do this. Marcus is going to save a certain amount of money per week. And I believe what they're saying about same amount is Philip is going to save an equal amount of money each week. So what they're saving per week is the same. Those two things equal. Okay, Marcus decides. Somebody to read. Thank you, Jerry.
Marcus decides to open a new bank account. He deposits $25 that he won in a robotics competition. He also plans on depositing $10 a week that he earns from tutoring. Philip decides he wants to keep his money in his sock drawer. He has already saved $40 from mowing lawns over the summer. He plans to also save $10 a week from his allowance.
All right, so we have two guys. We need to sort the two information because now they're going to want us to write a function to represent information more specifically about Marcus and Philip's saving. So if you have a highlighter, I'm going to highlight Marcus. This is all about Marcus. This is all about Marcus. Oh, I went over the name Philip. Really, we should do Philip info another color. So the first two sentences have to do with just Marcus, and let's see what he has. He deposits $25 that he won at a competition. So the first amount of money that he's putting in his bank account is his competition earnings, $25. Then he's going to tutor. He earns $10 a week tutoring. Okay, so if we're looking at how much money is Marcus going to have in his bank account based on the number of weeks he's saving, he's going to have $10 a week plus the $25 that he started with. Okay, Philip decides he wants to keep his money in a sock drawer. He already has $40 saved from mowing lawns over the summer. He plans to also save $10 a week from his allowance. That's a nice allowance. How many of you get an allowance? Do you, Oscar? Nobody?
I wish I'm here.
You do from your job. Okay, so $10 a week allowance. That's a pretty good allowance. No wonder he has money to spend on robots. Here we go. Here's the Philip information. Okay, so in these types of problems, we usually have a couple things going on. And with those couple of things, one thing you're going to need to do is sort it. Philip decides he wants to keep, he already has $40 saved from the summer, and then $10 a week is what he's going to do from his allowance. So if this is Philip's money total, okay, bless you, how are we going to write his function? Here's two pieces of information. How's that going to translate, Andy?
You put 10W plus 40.
Okay, so these guys look like they're saving the same amount per week, but they started at different places, okay? This guy got his money from a reward or award from a competition. This guy was mowing lawns, but this is what they had when they started. Then they're going to save a certain amount per week. Predict when Marcus and Philip will have the same amount of money saved. Use your function to help you determine your prediction. Predict when Marcus and Philip will have the same amount of money saved. All right? Let's see. Do they want us to do math yet? Or are we just going to guess a certain number of weeks? Let's do a guess right now. I'm going to give you 1 minute at your table. Tell me, in blank weeks, they will have the same amount of money. First, write that down. Second, turn to your tables, come up with a number. What do you think is a good guess estimate for when will they have the same amount of money? 1 minute starting now.
Are you sure?
Or use it, go to left. Yeah. What do you guys think? 20 more seconds, get a number down.
Never.
I mean, you can make a guess.
What depends? Do they start saving at the same time?
He says 7, so write it down. You guys have a guess?
Alright.
Pass through. 5 more seconds. 5, 4, 3, 2, 1. Write a number down.
Never.
Write a number down.
Never.
Okay. Who thinks they have a good guess? Andy.
Never.
Okay, that's his guess. He's going to say never. Who thinks there will be a day when they have the same amount of money? Is everybody saying never?
Yep.
He says never. I saw people with calculators. I heard estimates out there. Gary?
Do they start the same day?
As far as I know, yeah. Okay. That's a good question, though.
7.5.
Okay, so Andy says never. Sam says 7.5. Okay, and I bet
That was 20 days.
you guys can decide. It's probably somewhere around between never and 7.5, right? Wyatt, do you have a different guess? No, okay. I thought I saw a no back there, so that would mean a different guess. All right, top of the next page. You can prove your prediction by solving and graphing a system of linear equations. Rewrite each function as a separate equation. Use x and y for the variables of each function in each equation form and define the variables. Then write a system of linear equations. So we have our Marcus function over here where it says, here, I'm going to rewrite it so that you can see it all at once. M of W equals 10W plus 25. This is Marcus. They want us to rewrite that in terms of x and y. What variable, the x or the y, usually replaces the function notation? Okay. I'm saying x or y. What am I usually going to put right there? Y equals 10x plus 25. So both of these are different forms. This is function notation. This looks more like something that I'm going to do a linear function, a y equals kind of thing I can put in my calculator. All right, and that's Marcus's information. Now I'm going to do Philip and do something similar. It starts out P of W equals 10W plus 40. How do we write that? Y equals plus 40. So now over here, it's a little less clear what the x and the y is, so we're going to define our variables. X equals, it used to be W. What did W represent? Weeks. And y equals money. Money in their bank accounts. Analyze each equation. Describe what the slope of each line represents in this problem situation. Okay, in both of them, there's a 10 in front of the x. Slope for both is 10, because in y equals form, you find the slope in front of the x. We sometimes think of this in terms of rise over run, okay, or a change in the y versus a change in the, change in the y, that's not helpful, change in the x, okay. So what does this mean in our situation? For every one something, we'll get 10 of something else. For every 1 week, we will, what does that 10 mean? 10 is how y will change. And what is y? What does y represent? Money. So we will get 10. What kind of money? What units? Dollars. Is that an increase? Is it a plus 10 or a minus 10? More. So for both is 10, comma. For every 1 week, we will get $10 more. That's what that slope means. Over 1 up 10. What? Okay. How do the slopes compare? Marcus and Philip, what do you see? Same. What does that mean in terms of the problem situation?
Equal.
Equal what?
Equal slope.
Equal slope, but in the situation, what does that mean?
Increase in money.
Equal increase in money. Oh, that's getting too low. describe what the y-intercept says in each line. So for Marcus and for Philip, what's the y-intercept? Where do we find it in the equation? Here's Marcus's equation. Where's the y-intercept at? The 25. Here's the slope. It's in front of the x. Here's the y-intercept. So Marcus's y-intercept is 25. What's Philip's y-intercept, Oscar? Marcus's y-intercept was 25. What's Philip's y-intercept?
40.
You agree with them?
Yeah.
Oscar, do you need to come closer? I don't know if you can see that far. Philip's is 40. Okay, now, what does this 25 and 40, where did that come from?
That's what they say.
How much they start? What they start? Yeah.
Starting money. So before any weeks go, they had that money. How do the y-intercepts compare? The slopes were the same, but are the y-intercepts the same? How do they compare? How does 25 and 40 compare? One is $15 more. Describe what that means in terms of this problem situation. Who has more? That means that Philip starts with more. 6. Determine the solution of the system of equations algebraically and graphically. A. Use the substitution method to determine the intersection point. All right. Let's see how much of this, how to fit it all in. We're going to start, I'm going to have this, here, I'll get a separate piece of paper. You can be writing this down in A, but I want to do it on a separate piece of paper so I can show you these two equations. And my book is kind of sideways right now. Okay, this, we did not do this, well, we did it together yesterday. Folks, here we go. Substitution method. Take that out of your ear, please. Thank you. If I have two equations, and this is a system of equations, and I want to find out where they're equal, where they intersect, what do I do with this? I have them already in y equals form. Now I need to set up an equation that allows me to solve for the point where they crisscross. Who remembers the math of this? Molly? Set them up so they're equal to each other. So this is one version of what y equals. This is another. And at the point where they're equal, we can set those two pieces to be equal. Okay, so, whoa, there we go. So we're going to go 10x plus 25 equals 10x plus 40. This side of this equation went on the left. This side of this equation went on the right. Yeah. Now what do I do?
Let's see. You go minus 25.
Minus 25. Minus 25. From both sides, minus 25. This was a plus 25, so I added a minus to cancel out. That left 10x by itself. On this side of the equation, I'm going to minus that 25 from the 40 because both of these don't have x's. Now I've got 15 on the right. I want to move all x's to the left. How do I get rid of this 10?
Add it, subtract it, or subtract it. That's
Minus a 10, x, minus a 10, x. Uh-oh, wait a minute. 15 equals positive 10, negative 10. 0.
That's not right.
That's not right. That's not possible. Okay. No crisscross.
solution.
No. So you guys are right here in 6A. No solution. No crisscross.
That mean that was right?
Yes.
Yeah.
Does your solution make sense? Describe what this means in terms of the problem situation. What does that mean, Jerry?
Philip will always have $15 more.
Philip will always have $15 more. There is not a time when they will have the same amount of money. Okay. Where are we at on this guy? We'll stop that.